Hello. That's my name, and that's the exciting profession that I am in. I'll be talking about the QuickTime music architecture, which is a set of APIs and user interfaces specifically for dealing with musical notes on the Macintosh. Or in QuickTime, I should say. It's not just for Macintosh anymore. Good. So what does the QTMA do, the QuickTime musical architecture? It plays notes and music sequences. It can play individual notes, like hitting notes on a piano or other musical instrument, or play entire sequences without any further application intervention. It plays them at interrupt level, does all the timing management. In some ways, it's like a soundtrack. There's some significant differences from a soundtrack, especially in QuickTime, which is that the data is a lot smaller typically because it just contains the note information. It also lends itself to certain kinds of editing that a soundtrack doesn't. A soundtrack, all you can really do is change the volume or the playback rate. With a music track, you can do things like change what instrument it's played on at the delivery time as opposed to at the composition time. Okay, I'll be discussing 4 areas of QuickTime music architecture. The user experience, which is sort of the things a user might see that relates to QuickTime music, various dialogues and control panels. The contents of a QuickTime movie music track, the sort of data format that goes in there. I'll be getting into some very dry and boring API issues that sort of go over what sort of calls you can make to control the music architecture directly from an application, and a very brief discussion over how to write music components or synthesizer drivers that will work with the QuickTime music architecture. Okay, there's a couple of areas where the user will experience music. Probably the most common case is completely transparently as part of a game. Marathon, for example, uses the QuickTime music track, or as accompaniment to a QuickTime movie that contains a video, perhaps. They will experience more directly if they have to do any configuration with the control panel, or if they explicitly import a standard MIDI file, which is a common data format for musical information. So this is a picture of the control panel, which will ship with 2.1. It is also on the developer SDK. QTMA can deal with some fairly complex arrangements of musical devices and MIDI synthesizers, but the typical user has none of these things. He has just the built-in synthesizer. Of the remaining users who have external gear hooked up, most of them will just have a general MIDI box or maybe a NuBus or PCI card plugged in. So this picture of the control panel shows that a card called a Mac Wavemaker has been plugged in, so the bottom line fills in with the name of the card, because with a NuBus device, you can sense its presence and the driver can report that it's there. And the modem port is available for MIDI but isn't currently in use. I have a few more slides showing pictures of the control panel, but I think I'll just show you the control panel itself instead, if we could bring up the demo machine. Can we see the FX? Okay, so here we can see that the Mac Wavemaker card has in fact been selected. And there's some little text at the bottom which reads, QuickTime music is currently configured to use devices other than those shown above. What this means is that I've used a more complicated configuration utility to configure it for further devices that aren't supported in this sort of low-level configuration. Now, this is just a prototype of a more complex configuration. It's all done with public API calls, so a better one could be written and hopefully will be. This is a very user interface kind of kludgy one, but it shows the general capabilities. I've configured it here for 4 devices. The first one is the Mac Wavemaker. We get a pop-up menu showing which devices are available. And then I have 3 MIDI devices hanging off of the modem port also. You can choose which ports are available. The Mac Wavemaker hardware card actually has a MIDI port on it, so that's one of the available ports. And I've told them all that the control channel is MIDI channel 1. So that's the configuration I'll be using in my demos later. Slides, please. I think I already mentioned standard MIDI files is a common format for musical interchange. you can import standard MIDI files. Any QuickTime capable application that brings up a standard open dialog where the type MOV, movie, is enabled, alters, the standard input will allow you to import a movie file at that point from various types. In this case, a MIDI file has been selected and the save option has become a convert button. So if you were to click on convert while opening a standard MIDI file, this is in 2.0 by the way, you then get a save box, which is a little bit odd to get a save box from an open dialog, but it seems to work. From here, you can click on the options button, and then you'll get the ability to change what the instrumentation of the file you're importing is, and you'll get the instrument picker. There's actually one more dialog in between this. We get a nice stack of dialogues going when you do this operation, which shows all of the parts of the score. This is the instrument picker, which is one part being selected. This picker actually shows you the available synthesizers and the available instruments on each synthesizer. I will show that to you directly on the demo machine also. This is a very simple application, just has a few calls directly to the QuickTime Music Architecture API to bring up the instrument picker. So here we can select an instrument, say piano, and try it out. We have there we go. So here it's just choosing the so-called best synthesizer, which is in fact the first general MIDI synthesizer that it's aware of. In this case, probably the Mac Wavemaker. We can find out which synth it's actually playing on by clicking the About box. And we see that it is in fact the Mac Wavemaker. We can also specifically override its choice and choose a synthesizer. And here we get now two lists of instruments. One is the instruments unique to the device, say a detuned organ 1. Or we could say that we'd rather use a standard instrument, which is the general MIDI library, and choose perhaps a more mundane organ. You could also choose them both. Example, organ detuned 1 and the Hammond organ as the standard instrument, so that if you don't have a CM500, when you play back a sequence scored with this, you'll get the default instrument, the standard instrument, and organ. Okay. And here we have some pictures of what I just showed you, so explain those. A new dialog in QuickTime 2.1 is the instrument editor dialog. I'll show this demo at the end of the slideshow. One way to think of this is as a single dialog box that replaces some very expensive commercial editor and librarians. Well, that's not exactly true. There's still a lot of value in those products, but any synthesizer that has a QuickTime driver, you can at least get this very simple instrument editing dialog because the drivers report all of the parameters that define a sound for that device. Okay, these are a set of Helmholtz resonators, which were used by the groundbreaking 19th century acoustic scientist Hermann Helmholtz. He used these carefully prepared glass spheres to do primitive harmonic analysis of sounds. What you do is you hold one of them up to your ear and plug the other ear, and you can pretty much only hear sounds that fall within a very narrow frequency range. That was done in the late 19th century. Okay, inside a QuickTime music track. Okay, a QuickTime music track is just like any other track. It has a sample description, which is loaded into RAM when you run the movie, and then media samples, which are brought in as needed. Typically, they're all brought in on a music track because the data is very small. Up in the sample description is a list of which instruments are used for that track, and then down in the media samples is the notes and the timing of the track. It can also contain various control changes and knob changes as well. Okay, the sample description, deep inside it contains a list of note request structures, and a note request I will describe in a moment, but it's a data structure that specifies exactly what kind of musical instrument is requested for the part. It could also be a note request with a list of knob changes, which are adjustments to individual sound parameters for a specific device, and they're ignored if that device is not found. Okay, the sample description, as well as the media samples of a QuickTime music track, are all done in this sort of event format, which is a list of long words where the top several bits define the type of the event. Here is a variable length message, so that center long word could be any number of long words, and it's specified, the length is described at the top and bottom, so you can parse it backwards if necessary. In the case of a sample description, there's a bunch of note requests in there. The note request structure looks like this. It describes the polyphony of the note request, which is just the number of notes that you'll be playing simultaneously, so that it can allocate enough voices and make sure you're not going to run out of notes. It also has a typical polyphony, which is sort of the average number of notes playing. And this is used for volume scaling on the software synthesizer. You might have a maximum polyphony of 4 or 5, but a typical polyphony of 1 or 2, say 1.5. It's a fixed point number. And then at the very bottom is a tone description, which has more information. It describes which synthesizer you'd like the sound to be played on, or it could just be zeros. The name of the instrument in text. The instrument number for a particular synthesizer, and then at the very bottom, the general MIDI number. So if the particular synthesizer isn't found, that's the instrument that will get chosen to play it on. You can fill out this entire structure with zeros and just put in a general MIDI number at the bottom and get general MIDI sounds that way. Inside the media samples themselves are more events. I'm only showing 2 of them here, 2 different flavors of the note playing event. There's also rest events and control change events, but they specify the pitch and the duration of notes, values for control changes such as pitch bend and volume. There's 2 different flavors of the note event here because most notes can be represented in the shorter format, where the duration is fairly small and the pitch is within the range of 32 to 95, which is, well, I'm not actually sure which piano notes that is, but it's kind of the middle of the range, the middle 64 notes. It's less likely that they fall outside that range. The extended structure gives a longer duration field and a pitch field which is 15 bits, so you can actually specify a fixed point number for those synthesizers which would support microtonal scales. For example, the software synth, you can play C and 1/4 if you wish. And this is the harmonic analyzer used by Henrici. It's a very clever device based on rolling sphere integration. It sums the sines and cosines for 5 different harmonics simultaneously, as long as your waveform is exactly 22 inches in wavelength. Okay, now we're going to get into some very dry API issues. This is the overall structure of the QuickTime music architecture. Your application will typically talk to either the tune player or the note allocator, or to the movie toolbox, which probably should be in this picture but isn't. To play music, probably the easiest thing to do is just to call the movie toolbox and open up a music movie and play it. But you can also talk directly to the tune player where you shovel in chunks of sequence data, or to the note allocator where you can play individual notes after allocating a note channel. You can also write synthesizer components, and 4 of them are shown here. We provide 2 of the ones on this list, the Macintosh built-in and the general MIDI, which talks out through a MIDI port. I've written a number of drivers for various devices that I have access to just for testing. And we also have the Mac Wavemaker driver, which is an example of a NuBus synthesizer. So if you're talking through the movie toolbox, you get all the same functions as a typical QuickTime movie track. You can control the volume through toolbox calls, skip around in time, control the rate of playback, or disable the track entirely if you have, say, multiple music tracks within a movie or any kind of track. And like it says at the bottom, playing movies is easy. That's really the preferred way to play music if you have any choice about it. If you're talking to the tune player, you can do some fairly easy calls just to get sequences playing. You can play a sequence and you can queue up multiple sequence chunks which are played in order. It's a little bit analogous to the sound manager in that you can shovel in a bunch of data and then not worry about it until that data is empty. So some of the calls you can make here are tune set header, which is how you describe to the tune player component after you've opened it which instruments you would like it to be playing on. This takes a list of note requests, and it's the same format that's embedded in a movie in the sample description. Okay, you can find out which note channels and which synthesizers the tune player has actually gone out and used by calling getIndexedNoteChannel. So if you've called tune header with a 4-part header, then you can index it 1 through 4 and find out which synthesizer by getting the note channel, and then you can make some note channel calls, which I'll describe later, to find out information about it. Then the real interesting call is tune Q. This is where you actually shovel in a bunch of data and let it play without any further application intervention. So what you do is you pass in a pointer to a list of long words, which is the tune itself, and that's in the event format that I described before. The rate, so typically 1.0, but you can play it faster or slower. You can play just a piece out of the middle of that sequence by giving it the start time and stop time. And these are in arbitrary units. There's a call that I don't think I have a slide for where you've set the time scale. So the duration of the various events is described in those units. The default is 600, just like the movie toolbox. Then there's some flags where you can specify some finicky details that I'll describe in a moment, and a callback proc that gets called as each sequence is finished with your refcon. Okay, the flags you can pass to tune Q are to start now, which means don't wait for any previous sequences to finish. Just start playing them right away. Don't clip edges and exclude edge notes have to do with musical notes that are either already playing when you start playing this tune sequence, or notes that straddle off the edge of the tune sequence. So you can either have them clip or not clip. And loop until is a new flag in 2.1 that lets you loop a sequence indefinitely until a new sequence is queued up with another tune queue call. You can also find out what the tune player is doing with the tune status call. It will tell you very roughly where in the tune it is when you make the call and how much time has elapsed. The only fields in here that are really accurate is queue count and queue spots, which says how many more pieces of tune you can queue up into it and how many are already queued. In the music media handler for QuickTime, it typically fills it up until it's full and then waits for a queue spot to become non-zero so it can add some more samples. Okay, tune set volume just sets the volume of the entire tune, the entire sequence as it's playing. And that's independent of volume controls that are going on inside of the sequence. You can have, say, a fade-in of some instruments while it's playing. And tune Q adjusts it globally outside of those other controller changes. Pre-roll and unroll are interesting. It marks all of the note channels that are used by the tune player to be scavengeable. It's sort of like making a handle purgeable. It will keep them around unless some other application or another tune player wants them, in which case it will relinquish all of them at once. So you might do this on a window that's gone into the background, so it will continue to play, maybe after reducing the volume, until someone else needs those music resources. So tune pre-roll says, I need these channels, and tune unroll says they are scavengeable. So to play a sequence, all you really have to do is open up a tune component, call tune set header with your instruments, and then call tune Q with some sequence data, and music emanates. Okay, the note allocator is sort of where anything that didn't end up in the tune player or down in the music components has settled. This is where you would play individual notes. You open a thing called a note channel from the note allocator to play notes upon, but it also has calls for configuration to register a synthesizer with the system, as well as some convenience calls for user interface, like bringing up the instrument picker or the instrument editor. So to register a device, you specify the component type of the device, which is also the same as its synthesizer type. Actually, it's the component subtype. The component type is always MUSI for music component. Then there's a structure, which I don't have a slide for, called synthesizer connections, which if it's a MIDI device, it specifies the actual port connections. And this could be a MIDI manager port or an OMS port. Could also be a direct connection to a QuickTime port. We have some APIs for that. But basically specifies for an external device how it's hooked up. If it's a new bus device, it also specifies which of perhaps several cards it's in you're talking about. So you could have 2 new bus cards of the same type plugged in, and then there'd be a field in there which says use card number 2. Unregistered just takes it out of the system. So the control panel that I showed earlier makes these calls to tell the system which synthesizers you'd like to be using. Okay, how you allocate a note channel to play individual notes on, not a whole sequence. is with the new note channel call. You pass in a note request, which has the polyphony and the instruments that you'd like to use. And then it passes you back a note channel. And to this, you can make calls like play note and set knob and set controller. When you're done with it, you call dispose channel. When you close your note allocator component, it will dispose of any note channels which you allocated with that component. So if your application quits, the component manager closes all components that you've opened, which in turn will dispose your note channels. Pre-roll and unroll note channel is equivalent to the tune player pre-roll and unroll calls, except for an individual note channel. So again, it marks it as scavengeable. You can continue to play notes to it, and it may go silent if someone else needs those voices on the synthesizer or those MIDI channels, that sort of thing. Now here's some of the actual action calls. Play note and set controller. Play note, you pass it a pitch and a velocity, and that's the same as MIDI pitch and velocity, which is 0 to 127 for the pitch, where 60 is middle C. The velocity is 0 to 127. On some devices, the velocity changes the timbre of the tone. For example, a good piano synthesizer, it will sound different if you play the key very hard than if you play it very softly, not just louder. On the software synth currently, it just plays the sounds louder in a linear range from 0 to 127. The pitch, again, can also be a fixed point number with 8 fractional binary places. So you can play pitch C and a quarter or other microtonal values. Set controller is used to adjust various continuous ranges of controllers on a note channel, for example, volume or pitch bend. Most of the controller numbers are the same as their MIDI counterparts. We don't treat pitch bend as a separate MIDI signal. It's controller number 32 in our case. And you pass it a fixed point number, which is 8.8, 8 binary places. Pitch bend is also rigorously defined to always be in semitones. So a value of 256 or hex 100 is always a semitone up pitch bend. So there's no a set pitch bend range kind of notion. And these are a list of some of our controllers that we support. Nothing very exotic there. Volume and balance and pan have to do with stereo separation. Okay, then we have the set knob controller, which is something rather unique to the QuickTime music architecture to do with adjusting parameters specific to a certain synthesizer voice architecture. The knob number specifies which knob for a particular synth you're adjusting, and a knob number for, say, knob 3 will be different depending what synth you're on. The call will do nothing if you're not playing on the specific synthesizer you've requested. So you can actually sequence controller changes, parameter changes, that you previously would only edit in a instrument editor librarian type arrangement. Then we have some user interface calls. I already showed you on the demo machine what pick instrument does. It brings up a dialog for picking the instrument, but this is the entire call for it. It will fill out your tone description structure according to what the user clicks on. Then we have a new call in 2.1 for pick edit instrument, which actually can bring up either the picker or the instrument editor, which was that dialog with all the sliders in it for editing instrument parameters, depending on what flags you've set. So just to play some notes, if you want to play individual notes, handling all of the timing yourself, you would open up a note allocator component, type NOTA, fill out a note request structure, pass that to a new note channel, NA new note channel call, and then you can call NA play note to get some music out. When you're done, dispose the note channel. Harry Partch is one of my favorite composers. He was very into microtonal scales. And I don't think he would really approve of what we're doing here today. He seemed rather leery of electronic music. Okay, music components in 2.1. We provide a couple of them, a software synthesizer and a general MIDI component. We may provide drivers for a couple of very common synthesizers. That's unclear yet, maybe the Sound Canvas or the TG100. The other sound components that exist are anything that I had any synthesizer that I wrote a driver for. Then the Mac WaveMaker, which is a NuBus card, which is currently shipping, in fact, and is provided with a QuickTime component. So which components should someone write? Drivers for NuBus and PCI cards are probably useful to write. As we shift over to PCI bus, we can hopefully expect to see some lower cost synthesizer cards for the Macintosh. Think Sound Blaster or its descendants. Drivers for appropriate MIDI gear. You can actually write a driver for any piece of MIDI hardware. Whether it makes sense to do so is up to the author, I suppose. You can also write your own software synthesizer, so it might be interesting to write certain software synthesis algorithms. There are various algorithms which can be implemented fairly cheaply, especially on the PowerPC, which has pretty good digital signal processing capabilities to make sound. And certainly, the architecture would support components written to do that. Okay, the things that a component reports are its basic capabilities, such as its polyphony, its multitimbrality, which is how many different sounds it can produce at once, as opposed to its polyphony, which is how many simultaneous notes in a chord it can play. And then the list of knobs, which are parameters unique to that device. And it's this knob list which enables things like the instrument editor dialog to work. And what does it do? It controls the synthesizer. It has to implement calls like music play note and music set controller, which are quite analogous to their calls in the note allocator. The note allocator just calls directly down to the music component when it gets a play note for the correct note channel. Okay, the synthesizer description has a number of interesting fields that it has to report. The music component will report to the note allocator or anyone who queries it. The synthesizer type is just an OS type, a 4-byte ID. The voice count is its polyphony, how many simultaneous notes it can make. The part count is its timbrality, how many different sounds it can make at the same time. The instrument count is how many built-in instruments the device supports. So for a general MIDI device, the instrument count is 128. Various instruments may have a lot more voices in ROM than just the basic general MIDI set. And the channel mask is for MIDI devices specifically, and it says which MIDI channels the device can receive on. Because general MIDI supports a drum part on channel 10, we also kind of take a special case for drum parts. So we repeat those last 4 fields, the part count and instrument count, for the drum part of a synthesizer. So that way you can have one synth that has both drum instruments and musical instruments. Then there's some other finicky details like the output count, typically 2 for left and right. The latency, which is the number of milliseconds between the time that it receives a play note call and the time that music comes out. This is very useful for synchronizing different synthesizers. The software synth, for example, has a fairly long latency, but because we know that latency, we can synchronize it with external MIDI hardware. And then there's some bit fields that specify which of the general MIDI instruments are supported by the device. Okay, the knob description is for specific parameters on the synthesizer. And you might see this if you're writing a component or if you're querying a component because you want to edit its parameters. And it reports basically the name of the knob and its range, and then some flags that describe whether it should appear as a pop-up menu or as a slider, or if the slider has some units like milliseconds, you can report that. And then there's the instrument data structure, which is the tone description and then a list of knobs and their values. So if you have a custom instrument for a particular synthesizer, you can embed that into a QuickTime movie in this format, and you'll get back your custom synthesizer parameters when you play the movie. And I think this is self-explanatory. Now I'm going to move on to a couple of demos showing the use of the QuickTime music architecture. Okay, as I mentioned yesterday, I think every session should have a Netscape demo or two. Excuse me, World Wide Web. We're going to download a MIDI file and then have it launch a helper application.
Can't see how password. Yeah,
Well, I've just been informed that the network is down, but fortunately I do have a couple of MIDI files sitting around. Push-ups. I'm doing push-ups. No, really. I'm going to show you the importing of a standard MIDI file into QuickTime, and then how to use some of those dialogues to alter the sounds that it produces. And then I'll show you an application which is sort of a test sequencer application that uses almost all of the features of QuickTime music. I like the new version of the Mac OS because it boots faster with the smaller bar. Yeah. Okay, this is a small application which was designed primarily as a web helper app. It's a lot like Movie Player.
It's back up.
Oh, the network's back up. Should I try it? Yeah. Okay. Mm-hmm. Okay, I'm going to download a fairly sizable MIDI file, 112 kilobytes. Hopefully the net's up enough that it arrives in a reasonable time. Hmm, 700 bytes a second. We like that. Now the helper app that it's going to invoke is a lot like Movie Player, but it's been sort of aimed as a helper app in that it imports the file and keeps it in RAM as a RAM-based movie using the handle data handler. And it also adds a little visual track to go with the music track. So it won't prompt you to save it as you open it, which is what typically would happen in a movie playing application. It's a lovely piece. Okay, the musical notes means it's importing the file now out of standard MIDI format and into QuickTime Music format. There's a lot of notes in this piece. Okay, so it's added a single frame video track now, which is just one frame that spans the entire duration of the movie. And it's done that by parsing through all of the media samples of the music track and given some information about it. So here we can hear it now. Okay, so this is a pretty simple use of QuickTime music. It's just imported a file. It's got 13,000 notes and it hasn't choked, so that's kind of a good thing. Now we can skip around in here. A new feature in QuickTime 2.1 is that you can play it backwards. So if we command-click on the left arrow, so we can hear the Brandenburg Concerto backwards. Now we can also go in here and alter the scoring. Where's my cycles going? So if we want it to sound like perhaps some electronic music out of 1967, we can choose square wave for half of it. And maybe saw wave for the other half. Good classic synthesizer sounds. So there, now we are at the shopping mall. Ooh. Okay, so that's interesting. It doesn't really use a lot of QuickTime music architecture, but it's a very solid practical example, trendy too. It's got the web, the whole bit. Okay, now this is an application I've been writing sort of as a test tool. It uses almost all of QuickTime music architecture. It doesn't go through the movie toolbox. It calls QTMA directly. Pardon my user interface. But what we can do here is set up little sequences. First we'll give it an instrument, say bass. Choose some notes for it to play. So is that making any sound? Okay. Then let's say we actually want to play this on one of the other synthesizers, the MT32. No, the sound canvas, the CM500. Now, in here we can control some synthesizer-specific characteristics, which normally you would only be able to get to from an instrument editor. So let's go ahead and have the filter changing while it's playing. So that's something you can't usually do very easily from a sequencer program, but the API makes it fairly straightforward with QTMA. Do the same thing with, say, another instrument. Let's choose FB01, which is an old Yamaha FM synthesizer. And we'll change some of the FM parameters while it's playing. So now I think this may or may not work. Last time I tried it, it was sort of limping along, but I think I'll go for it anyway, what the heck, is actually saving this into a movie. So it should save all of these parameter changes into a movie. This is just recording sort of real time while it's playing. Okay. Now let's see if that movie actually works today. It may or it may not. Actually, we'll run it through the music player instead. And we got 0 notes. Okay, sometimes we get 10, sometimes we get 50, sometimes we get 0. It's a bug. So always end with a bang, and that's the end of this demo. And at this point, I'll take questions and answers. Yes?